Hi guys, I'm Manjunath. We the team from Griffinders. We are again back with our new idea for the problem statement SIH1387 given by the Ministry of Power. So let me show you what is the problem statement and what we have suggested for that. So the problem statement was given by Ministry of Power and this is the problem statement code, and the problem statement is detection of embedded malware or Trojan in hardware devices used in the power sector. And so for this we have designed an idea. So let me show you, and this theme comes under the blockchain and cybersecurity. So this is the idea that we have proposed. So coming to the types of hardware Trojan and what is meant by Trojan first. See, what is meant by Trojan? Trojan is nothing but it is a type of a payload. Like it behaves as a malware which can be used for hacking the device. Simply it will be injected in hardware and software, but here they have given for us to detect in hardware only. So what happens? Say mainly in the process of manufacturing any hardware, like let me show you a board. So this is the FPGA. It is called as FPGA, and the full form of FPGA is field programmable gate array, in which we can able to program and we can use it accordingly. So this is the Spartan 3 FPGA board that we have got from our college, and this can be configured and programmed in this Xilinx Vivado software. So this is for basic purpose only, and for implementing this type of project we need Arctic 7 FPGA that I have mentioned here. As you can see, Arctic 7 FPGA field programmable gate array, and it looks like this, and it costs around 29,000, but we can simulate it in this Xilinx Vivado. For the basic prototype this is enough. So we are already into the prototype and we have completed the 90% of the prototype, and the simulation part will not be shown in the video because it will be a copyright. So next, I have said what is meant by Trojan. So let me explain. Like this board is manufactured from different companies, right? Firstly it should be prepared. The most weakest part of preparing this board is fabrication part, where we don't know whether a hardware component or a malicious component known as Trojan is inserted herein or not. So what we need to do is we need to detect this. So how this can be detected? That is our idea. We have proposed our idea to how to detect that. So coming to the types of hardware Trojan, like there are two types of hardware Trojan mainly. One is combinational Trojan and second one is sequential Trojan. So sequential, as you know, sequential is nothing but a memory based, so by which it triggers. Like coming to the Trojans, what happen is the malicious activity will takes place by executed by, like it will takes execution by the support of a hacker, the one who inserts the Trojan in the board. What the hacker will do is he will access the Trojan by triggering it. So whenever, suppose let's take this board, whenever there is a triggering happen in this, the logic gate will be placed by the hacker only. Like the Trojan, I said before, Trojan is nothing but a logic gate. There will be two types of Trojan. It can be analog Trojan or digital Trojan. Here I am talking about digital Trojan because digital Trojans are most difficult to identify and they play crucial role. Analog Trojans can be easily identified. So this type of digital Trojans will get triggered by that hacker, and once this type of triggering happens, what will happen is there will be a payload attached by the hacker. So the payload is nothing but he will design after the triggering of the Trojan what should happen to the hardware. Like suppose, let me say an example, we will go into a army. So in army what there will be many of the weapons, right? Let us take an example of missile. So whenever let's take our Indian army, whenever Indian army missile is designed by other countries, then what they will do, suppose they have injected a Trojan. Okay, we will assume a digital Trojan was injected by them, and what will happen is after injection of the Trojan it will trigger according to it. Like whenever the hacker requires, he will trigger, right? So at the time of the war what will happen is we want to use that missile, so we will turn on. But what the hacker will do is at that time he will use the Trojan, he will trigger it, by which the payload will get executed by a driver, which can be any of the driver like HTT driver, which will be inserted by the hacker. So what will happen is it will get turned off, it will behave according to the hacker. which was operating this in the other country. So this is very crucial. So identifying the Trojans in this hardware is very difficult, but identifying is difficult, but the process and the execution part will be very easy. That can be explained here. See, as we have explained here, coming to simplified architecture, as you can see here, this is the simplified architecture of an FPGA, showing the trigger points that a Trojan may use. Like I have said this before, this is the FPGA. So what we will do is we will run an analysis. This is a golden circuit, we will call as, because this is Trojan free. We will check this first, and the simulation results of a Trojan project, like Trojan subjected board, will be compared with this, and according to that we will decide whether it has a Trojan or not. This is one type, and this is type of architecture, as I said before. So this is a FPGA architecture where it is showing the triggering points, like where hacker can insert the Trojans here, and you can see this. Here is the adder logic, configuration cells, logical testing we can do. So basically for detection of Trojans we have two types. One is destructive detection, second is non-destructive detection. In destructive detection, what will happen is, firstly, let's say this is a FPGA, I have said before. If I do destruction Trojan, this destruction attack to detect the Trojan in this, what will happen is the board's data will get damaged, like the functionality will get damaged. So there will be many logic gates in this, and the logic gates functionality will get damaged because of the testing. Like we can do temperature testing, thermal testing, right? So at the time of thermal testing, what will happen is, when going to the high temperatures, one logic gate will behave according to one temperature. So temperature based logic gates will gets operated. So because of that, to identify the Trojan, remaining logic gates will get damaged. So this is destructive. This destructive approach is not encouraged. So what we want is an easy way of approach and non-destructive. So that we have projected here. One is power side channel analysis, as you can see in the right part here. So here you can see this is the basic simulated power side channel analysis, which can be done in the Xilinx Vivado board by connecting this board. We have run this analysis, and this is the screenshot of that. So as you can see, the simulation part will show, we'll compare. Before I said this is a golden circuit, the power will be given to this, and we will observe the current and voltage fluctuations in the simulation of this board versus, in parallel with the Trojan projected board, Trojan subjected board. So by which we can observe, we can detect the variations, and we can spot the Trojan, and we can remove it. So this is the very easiest way. And also there is a ring oscillator technique, but ring oscillator technique was used here whenever there is more complexity. Like see, if the Trojan is very minute, very nano, so then the complexity is high, where we can't use this power side channel analysis. There we will use this type of technique known as ring oscillator technique, where the frequencies, the oscillator will generate the frequencies, and the board specification will have some frequency. Whether the board specifications frequency is matched with the ring based oscillator's frequency will be checked by the software, and if that matches, there is no Trojan. If it does not match, then it implies there is a Trojan in it. In this way, the non-destructive approach has two methods. One is, as I said, the first one is power side channel analysis, second one is ring oscillator. There is third one also, but where we need to implement the logic based testing. It is the logic based testing where we will see the logic. Like see, if I am using a FPGA board, I want to have one desired output, right? So if I want that one desired output, I will check based upon the logic. Similarly, if I am not getting the output, that implies there is a Trojan there. So it is not that easy, because there will be thousands of logic gates where we can't do that much calculations and find the logic for the input and output. So it is very difficult, but if there is no other way, then we will go for that. So these are the three types that we are using, that we are offering right now in this idea. We are projecting in this idea. So according to me, the power side channel analysis is very cheap. Like we can do it in a simulated part for minimum Trojans. Most of the manufacturers or hackers will just do will inject a normal type of combinational sequential types of Trojan, as you can see here, synchronous Trojans, asynchronous Trojans, and this hybrid Trojan is used for collecting the data also. this is a type of Trojan where it can be combinational and also sequential, where you can store the memory, you can do the operations, it can take the information. It's a hybrid Trojan which can be injected only by professional hackers only. So many, at most 99% of these Trojans can be detected by using this power switch analysis. By 1% we will use this ring oscillator or logic based testing. So this is our idea. So this is our solution. As you can see, according to the problem statement by the respective authorities, we have designed all this. And there is only requirement of two technology stacks here. One is Arctic 7 FPGA, because they have asked for a hardware. We need this. This was manufactured by the DigiLinks platform. As of now, we don't have this board. We only have this Spartan 3 board and basic board. That's it. And this is the Xilinx Vivado software where we will run the power site analysis simulation. So hope you got understood this idea that proposed by us, and our prototype is almost 90% completed. We have run the simulations and I have projected the screenshot for that also. Next, coming to the use cases, as you can see, these are the use cases like implementing continuous monitoring. We can monitor the continuous and regular updates from the security measures, like the Trojans analysis will be done in the simulation, but as I said before, and regular hardware inspection can also be done to secure communication devices. This is very important. And collaborative with cyber security experts and agencies to assess and defend against hardware threats, because we need to also collaborate with the cyber security experts, because there is a chance of also implementing the hybrid version of Trojan like hardware plus software. This is also a case, so that's why we have included here. Supply chain verification is the last case. As you can see, this is the giving a unique access code at the time of fabrication only to avoid the Trojan insertion. And dependencies or showstoppers is it is very efficient in cost. There is just requirement of a board, and simulation part is open source, and we can able to collaborate with manufacturer also. Like we can propose the idea that Trojan free, so that business will get increased. And supply chain security is playing a very key role here, because there is no chance of insertion of a Trojan. And this is our idea. So hope this idea goes further, and hope in the future there will be no chances of inserting Trojans into the hardware. That's it. Thank you. Jai Hind.